Good evening, everyone. How are you tonight? I hope you had a nice week. It's the weekend, yeah. But you are there and you are brave and you want to do more economics before the weekend. Let's do that together. Is it okay? Can you tell me if you can hear me, if you can see me, if you can also see the PPT? Same thing, please use the chat box just to let me know if everything is working properly. And then we will get started. Is this fine? Good. Okay. All right. So tonight I am starting a new series of webinars. The objective is to cover the beginning of the second unit of the A2 syllabus, the price system and the microeconomy. So I have already covered market structures in the previous series of webinars. The objective now is to try to cover everything before that. So consumer equilibrium, production in the short run, production in the long run, revenue curves, profit, the objectives of firms, everything that comes before market structures. And well, I guess then the logical thing to do afterward would be to move on to Unit 3, Government Microeconomic Intervention. Okay, so let's start. And today we'll focus on two things. I'll say a few things about budget lines, which is usually very easy. And then I'll talk about preferences, utility, and indifference curves. So that will be the part A of the webinar on consumer equilibrium. And then part B will be about how we actually find the equilibrium. We'll talk about the equimarginal principle, and we'll also talk about price effect, substitution effect, income effect in the case of normal good, inferior goods, ordinary goods, and different goods. All right, so let's start with budget lines. Okay, oops, that's not, sorry, made a small mistake. And my computer is not going very fast tonight. Okay. All right, so a budget line, we'll use some letters, parameters, and variables to describe it. So let's use some letters. Let's just call, every time you will see W in this PPT, it means income. It's quite standard in economics to use W for income. Px is going to be the price of good X, and the good X and the quantity of good X will be labeled on the horizontal axis. Py will be the price of good Y, and we will label the quantity of good Y on the vertical axis. Easy. Lowercase x is a quantity. That's the quantity of good X that we purchase. And lowercase y is same thing. It's a quantity. It's the number of units of good Y that we purchase. Okay. So the vector xy that we have there, the combination of xy is what we call a bundle of good X and good Y. We can also call that a basket. So it's a quantity of good X and a quantity of good Y, which means that it's a point in this plane. We have the plane XY, and that's simply a point in this surface. If you don't, you can say a surface. Okay, so the budget line is simply the description of the budget constraint, which is a simple idea according to which you cannot spend more than what you have. So if we want to be able to describe and to compute the budget line, we have to write on the one hand what we have, our income, and on the other hand, what we spend, our consumer expenditure. So remember that we make a simplifying assumption according to which there are only two goods that I can buy, good X and good Y. I can only spend my income on the purchase of good X and good Y, okay? So my consumption expenditure is simply X times PX. So the quantity of good X that I buy times the unit price of good X So XPX is my expenditure on good X, and YPY is my expenditure on good Y. So this is what I spend. What I have is W, my income. So the budget constraint simply tells me you can't spend more than what you have. So your income must be greater than or equal to your expenditure. Okay, that's what we call the budget constraint. And the budget line itself is simply the combination of good X and good Y, or all the possible combinations of good X and good Y, such that the consumer spends all its income. So you see that if we go back, if we look at the budget constraint, it tells me that my income can be either strictly greater than my expenditure, or it can be equal to my expenditure. And the budget line is simply going to tell me, or to give me, let's forget about this sign there, let's forget about up, let's forget about that. It's simply going to give me all the combination XY such that my income is equal, no, we don't see very well, but equal to my expenditure. Okay, so that's how we can define the budget line. It's a very simple definition. The budget line shows all possible combinations of two goods, good X and good Y, such that the consumer is able to purchase these combinations when it spends all its income. So income is equal to expenditure at all points that lie on the budget line. So the equation is simply income is equal to expenditure. You see now it's no longer greater than or equal to, it's simply equal to. W is equal to XPS plus YPY. And if I rearrange a bit this equation to have Y as a function of X, I can rewrite it this way. Y is equal to W over PY minus PX over PY times X. Why is this interesting to write it like that? Because all your students, they know how to graph this type of functions. You know that this is pretty much something like Y is equal to AX plus B, right? This is this type, this is the equation of a line. They will realize that this is the equation of a line, and you can actually use the equation to see that in this case, we have A, if you want, A that is equal to B minus PX over PY. Okay, so that's going to be the slope of the budget line, and B is equal to W over PY. Okay, so that's the vertical intercept. The vertical intercept is W over PY, and the slope of the budget line is minus PX over PY. We could also see that the horizontal intercept is going to be equal to W over PX, but from an intuitive perspective, as I will explain in a minute, okay? So I think it's a good idea to start, to give the equation of the budget line. It's important to start from income is equal to expenditure. It's a good start. And just to rearrange it, because it is an implicit equation, to just rearrange it, to put it on the form Y is equal to AX plus B. Why is this interesting to give the equation? Because then, if your students, if they remember this equation, it's going to be very easy for them to know what's going to happen, how the budget line is going to shift when we change W, PX, or PY. They simply have to look at the equation and see what happens, okay? So, well, perhaps this is too much math for some, but I think usually it's not a big issue for most A2 students, at least in China. I don't think any of them will have problems with that. Okay, so that's the equation of the budget line. And the budget line works essentially like a production possibility curve. There are many similarities, since all the combinations of good X and good Y, which are above the budget line, they are not attainable. When we looked at the PPC, we said that we don't have enough resources, factors of production, to produce any combination above the PPC. In the case of a budget line, it's not really that we don't have enough physical resources, it's that we don't have enough financial resources, right? We don't have enough money, we don't have enough income to purchase any of the combination XY which are above the budget line. What happens if we are below? any combination that is below the budget line is attainable in the sense that we have enough income, or we have enough purchasing power, let's put it this way. We have enough purchasing power to purchase these combinations of good X and good Y, but we will not spend all of our income, which means that we will have some income left. And the income that we have left, we sometimes call that the residual income. And finally, all the points, all the combinations of good X and good Y which lie on the budget line are attainable. I have enough purchasing power to purchase these combinations, and they are such that, by definition, they are such that the consumer spends all its income, so the residual income is zero. Okay? All right, so on the budget line, attainable, and we spend all the income. Below the budget line, attainable, and we have some income left. Above the budget line, there is no income. It's not attainable. Good, so here's how we can graph it. So on the horizontal axis, we have the quantity of good X, and on the vertical axis, we have the quantity of good Y. And simply looking at the equation that we have there, we know what the vertical intercept is, we know what the slope is, and the horizontal intercept is just W over PX, which makes sense, right? If we look at the two extreme points, if we look at the horizontal intercept and the vertical intercept, let me emphasize them. Okay, if we look at these 2 points, so the vertical intercept there and the horizontal intercept there, it makes sense that it's W over PY and W over PX. For example, let's say that we have 2 good pizzas and Coca-Cola. Let me write a few notes so it's going to be easy for everyone to remember. So let's just say that W is equal to $1,000, okay? And the price of a pizza, PP for price pizza, is equal to $10. And the price of a bottle of Coca-Cola, okay, so P, that's going to be CC, Coca-Cola, is going to be $2 per bottle. These 2 points, the vertical intercept and the horizontal intercept, would be a situation in which the consumer uses its entire income to buy just one good. Yeah. So for example, the vertical intercept would be a situation where the consumer only buys, let's say, pizzas, and the horizontal intercept, let's say that pizzas are a good Y. Okay, that's going to help us. Pizzas are a good Y, and Coca-Cola is going to be good X. So that's going to make things a bit more clear. Okay, so right there, a vertical intercept, we only buy pizzas, we don't buy Coca-Cola. So with an income of $1,000 and a price of a pizza of $10, how many pizzas can we buy? Well, if we spend all our income, we can buy 100 pizzas, which is just W over PY. Okay, W over PP in this case, price of pizza. And if we look at the horizontal intercept, this will be a situation where the buyer only uses its income to purchase Coca-Cola. With the price of a bottle of $2 and an income of $1,000, our consumer can buy up to 500 bottles of Coca-Cola, which is just the income divided by the price of a bottle of Coca-Cola. Okay, so it just makes sense. It just makes sense that the values of this vertical and horizontal intercept just make sense. Okay, and remember and emphasize that the slope of the budget line is simply the price ratio, simply because this is the price at which the market will substitute one good for the other. All right, so if you, let's say you buy one less unit of one good, let's say you buy one less unit of X, then you save PX, and with PX you can buy a PX over PY units of good Y. And so that's the rate at which you substitute the two goods. The market substitute the two goods. Okay, well, so far I think there is really no problem at all. So let's move on a bit, and what you can do with your students is to show them different points, yeah, A, B, C, and to ask them, what can we tell about point A? Is this attainable? Do we have income left? What about point B? Attainable, yes or no? Do we have income left? And the same thing for point C. It's always good to practice at the beginning. And then what is important for your students is to know what's going to happen when we change income, when we change the price of X, and when we change the price of Y. So you have 6 possible changes because each parameter can either increase or decrease. So what if we change income? You know, the first thing you can do is to go back to the equation and to look at where W is in the equation. We see that the slope is Px over Py, okay? So if we change income, if we change W, this will have no influence on the slope. The slope is not going to change. On the other hand, you see that the vertical intercept is depends on W, and it is positively related to W. So if you increase income, then the vertical intercept is going to increase. And if you decrease the income, the vertical intercept is going to decrease, W over Py. And since the slope remains exactly the same, it's straightforward to see that if we decrease income, we'll have a parallel shift inward. Okay, the budget line will still have the same slope, but it's going to be closer to the origin, if you want. So same slope, but a lower vertical intercept. Now it's W prime over Py, and also a lower horizontal intercept, W prime over Px. The slope remains the same, Px over Py, simply because the price ratio has not changed at all. And if we increase income, this is what the right-hand side diagram shows, then same thing, it's not going to affect the price ratio. So the two budget lines are going to have the same slope, parallel shift outward, further away from the origin. So the vertical intercept and the horizontal intercept are both going to increase. Okay, well, I'm not going to spend too much time on that because it's really self-explanatory. What if we change the price of good X? Okay, so same thing. What you can do is to go back to the equation there and say, okay, what if we change the price of X? Is this going to change the vertical intercept? The vertical intercept is W over Py. So it doesn't depend on Px. So the vertical intercept will not change when you change Px, price of X. Is it going to change the slope? Yes, the slope is Px over Py in absolute value, okay? So if you increase Px, you see that the slope is going to become steeper. And if you decrease Px, you see that the slope is going to become flatter. That's it. You see, simply with the equation, you can find out what's going to happen to your budget line. So these are our initial budget lines. What if we increase the price of X? That's what's going to happen on the left-hand side diagram. As I said, the budget line, the vertical intercept doesn't change. It's still W over Py, but the slope is going to become steeper. Boom. So steeper slope, now it's going to be Px prime, which is greater over Py. And of course, we will have a new horizontal intercept, W over Px prime. So that's what happens on the left-hand side diagram. What's going to happen on the right-hand side? So same thing, if we decrease the price of X, the vertical intercept W over Py is not going to change, but my budget line is going to become flatter. So basically, we will have a shift along the horizontal axis, an outward shift along the horizontal axis, whereas we had an inward shift along the horizontal axis in the case of an increase in the price of X. Okay, so on the right-hand side diagram, the price of X decreases, leading to an outward shift along the horizontal axis of the budget line, and we have a new slope that is flatter. So the budget lines are no longer parallel, they don't have the same slope anymore. And that's about it. And finally, what happens when we change the price of good Y? Same thing, go back to the equation, boom, boom, boom. If we change the price of Y, is this going to affect the horizontal intercept? Yes. Is this going to, sorry, the vertical intercept? It's going to affect the vertical intercept, W over Py, yes. Is this going to change the slope? Yes, Px over Py. Is this going to change the horizontal intercept? No. The horizontal intercept is W over Px, so if we change Py, this will not change the horizontal intercept. But the slope of the budget line is Px over Py, so if we increase Py, then our budget line is going to become flatter. And if we decrease Py, our budget line is going to become steeper, right? So using this information, we can just graph what's going to happen. Okay, so we start from there, initial budget line. Let's have a look at the left-hand side diagram first. So we increase the price of X, the horizontal intercept doesn't change, so we will still start from this point there. But if we increase the price of Y, Px over Py, the slope is going to decrease, which means that our budget line is going to be flatter. So we have an inward shift of the budget line along the vertical axis now, and we have a new vertical intercept, W over PY prime. If the price of Y decreases, this is what happens on the right-hand side diagram. So same thing, the horizontal intercept will not change. It's going to remain W over PX. But if we decrease PY, the denominator is going to be smaller. Therefore, the ratio is going to be bigger. PX over PY will increase. So the slope of our budget line is going to be steeper, okay? So we are going, the budget line, in the case of a decrease in the price of Y, is going to shift outward along the vertical axis. And we will have a new vertical intercept, W over PY prime. Okay, so in this case, in this example, I only considered one change at a time. You see, I only considered a change in income or a change in the price of X or a change in the price of Y. But there are many MCQs where your students are expected to combine two changes at the same time. For example, a change in an increase in income and a decrease in the price of X or something like that. There are many MCQs where they give you an initial budget line and a final budget line. And basically they ask you, how did we move from the initial budget line to the final one? So your students must practice and to feel comfortable with the effect of these changes on the shape of your budget line. Okay, what you can do to practice with them, I've created this example. We have Belen, and she has an income of $96, and there are two goods in the economy, Peruvian flutes and kites. So I give Belen's income, and I also give the price of flutes and the price of kites, okay? So PX, PY, and W. So I have all the information. And here are the questions. What is the maximum amount of Peruvian flutes and kites that Belen can buy with her income? So basically this means if she only uses her income to buy just kites or just flutes, how much can she buy at most? Okay, so it's going to be the vertical and horizontal intercept of my budget line. Second question, if Belen buys 4 flutes, how many kites can she buy? All right, easy. Does she have enough money to buy 2 flutes and 6 kites, 6 flutes and 6 kites? Okay, so basically I'm finding a point below the budget line and a point above the budget line. Draw Belen's budget line. Show how the budget line will shift, and I consider 3 changes: a change in income, increase in income, a decrease in the price of one good, decrease in the price of good Y. I think Peruvian flutes will be labeled on the vertical axis, and an increase in the price of good X, kites, labeled on the horizontal axis. Okay. I don't know if I have the keys. I know that I have the, I have the budget lines, but I don't have the answers to the first question, so we can do that together very, very briefly. So what is the maximum amount of Peruvian flutes that she can buy? Okay, let me type the answer very briefly. So the maximum amount of flutes is simply W over the price of the flute. W is the income. So W is 96. And the price of a flute is 12. So what is it? Is it 8, right? Am I correct? 8 flutes. 8 times 12 should be, yes. Okay, so that's the maximum amount that she can buy. What is the maximum amount of kites? So same thing, it's W, the income, divided by the price of a kite. So W is the same, it's $96. And the price of a kite is $6. So what is it going to be? 16, am I correct? 16 kites. Yeah, that's it. My mental calculus is not so great anymore, but I think it's correct. Okay, if Belen buys 4 flutes, how many kites can she buy? So first you have to find out what is the cost of purchasing 4 flutes. All right, so to purchase 4 flutes, so it's going to be 4 times the price of a flute, which is $12. So it's $48. Okay, so what is left? We can call it the residual income. What she has left is simply the total income minus what she has already spent. And well, guess what? She had already spent half her income. So she only has $48 left. Okay, that's her residual income. That's what she has left. And finally, then with the remaining $48, how many kites can she buy? Well, kites will simply be 48, what she has left, divided by the price of a kite, which is $6. Up $6, which is going to be 8. Okay, 8 kites. So basically, if she has already purchased 4 flutes, she can purchase 8 kites. I hope I'm not making any mistakes because I don't remember what the answers are. So if I make a mistake, feel free to let me know. Does she have enough money to buy 2 flutes and 6 kites? Okay, let's find out. So what is the cost? Let's just do this as a function. This is not exponential. This is the expenditure for 2 flutes and 6 kites. So this would be 2 flutes times the price of a flute, which is $12, plus 6 kites times the price of a kite. So it's going to be, that's going to be $24 plus $36, which is $60. So it's less than $96, which is her income. So the conclusion is that yes, of course, she can buy 2 flutes and 6 kites because it only costs $60 and she has $96 of income. So it's actually going to be a point below the budget line. Can she buy 6 flutes and 6 kites? Okay, so let's do the same thing. Let's compute the expenditure when I buy 6 flutes and 6 kites. So it's going to be 6 number of flutes times the price of a flute, $12, plus 6 kites times the price of a kite. So that's going to be $72 plus $36, which would be $108. So it's greater, strictly greater than her income. So it's not possible. She does not have enough income to purchase 6 kites and 6 flutes, which means that this combination of good X and good Y, or flutes and kites, will be above Belen's budget line. Okay? Can I erase? Should be able to, right? I'm going to erase it. I count until 3. 1, 2, 3. Okay, I erased the answers. Boom. All right, so with the information, we can now draw the budget line. So remember that these were our answers, the maximum amount of flutes, Peruvian flutes and kites that she could buy. This was the question, this was the second question. If she buys 4 flutes, how many kites can she buy? We said 8, up for 8. So this has to be on the budget line. And yes, these three points will be on the budget line. Then we had the question, can she buy 2 flutes and 6 kites? And we said yes. So, and we said there is money left. She had income left, 2 flutes and 6 kites. It's possible, but she had, it only cost her $60. So she didn't spend all her income. So this is represented by a point below the budget line. And finally, we said, can she buy 6 flutes and 6 kites? And we said no. She doesn't have enough money for that. And we see that 6 flutes and 6 kites is indeed a combination that is above the budget line. She needed $108, but she only had $96. She didn't have enough money to purchase this combination. Okay, so this is the budget line. Last question, what happens if income rises to $108? So you know that if income rises, we are gonna have an outward shift, a double-sided shift, if you want, of the budget line. It's going to shift outwards, and you see that the slope is going to remain the same simply because the price ratio has not changed. Okay, you can compute the values if you want of the new vertical intercept and the new horizontal intercept. What is going to happen if we increase the price of, we decrease the price of flutes? So flutes are on the vertical axis. Okay, so we start from there. We decrease the price of flute. So in this case, you know that the budget line is going to shift outwards along the vertical axis. The horizontal intercept doesn't change because we have not changed the price of kites, but the price of flutes has decreased, so the vertical intercept is going to increase, to shift upward if you want, and the budget line is going to become steeper. So if you want, you can calculate all these values, right? The new vertical intercept, the new slope, and all. And finally, what happens if the price of kites increases? So if the price of kites increases, so we start from our initial budget line, so the vertical intercept is not going to change because W over the price of flute doesn't change, but the price of kites increases, so the budget line is going to shift inward along the horizontal axis. So the budget line will become steeper because Px has increased. The slope increases from 1/2 to 4/3, and the horizontal intercept will decrease from 16 to 6. Okay, I don't want to spend too much time on this because I really think that this is easy for everyone. Usually the students, they do very well. Feel free to use if they use mini whiteboards, make sure your students use mini whiteboards to complete this type of exercise. And I think this is a great startup activity or startup exercise just to make sure that they have understood all the concepts related to budget lines. Okay, and we are done with budget lines, which is basically about what people can buy and what they can't. You see that so far we haven't talked about what they want. We don't know if Belen likes kites more than flutes or whatever. It's not about what they want, it's only about what is possible. The set of all possible combinations of goods and services, everything that I can buy. So it's nothing, it's absolutely not related to what I want to purchase, not related to my preferences. Good. Do you have any questions at that stage? Anything that you'd like to ask before we move on and talk about utility? Are we okay? Shall we move on? Okay, I'll take this as a yes. All right, so now let's talk about what they want, what consumers want. Let's talk about utility, which is pretty much their satisfaction. The first thing that you should say is to explain the difference between total utility and marginal utility. So total utility, I will just call that TU, and marginal utility just MU. Okay, so if I say MU, marginal utility. So total utility, okay, so let's start first with just saying that satisfaction in economics for consumers is often something that we call utility, and the unit that we use to measure utility is a util. Okay, well, that's the unit that we use. Okay, total utility, it's quite simple. You take a bundle of goods and services, a combination of goods and services, and the total utility associated with this combination of goods and services is simply the overall satisfaction that is enjoyed by the consumer when consuming this given quantity of good X and good Y. Okay, so it's like the global utility, the overall utility that is enjoyed when we consume several units of several goods altogether. And the MU is different. We only look at one good, one single good, and we look at the change in total satisfaction, the change in total utility when I consume one additional unit. So you could say one additional unit, or you could say the last unit. Usually I prefer to say the last unit. We look at the satisfaction that has been provided or generated by the consumption of the last unit of one particular good. Okay, when we talk about MU, we only look at one good. So it cannot be the MU of X and Y. It's either the MU of good X or the MU of good Y for a certain given quantity. Okay, so if we calculate the MU of good X for the fifth unit, it's basically by how much total utility has increased when we have consumed the fifth unit of good X. A simple example to illustrate the difference between total utility and MU If I eat 3 waffles and 4 pizzas, I get a TU, total utility, of 100 utils. Okay, so you see that it's the total utility is the outcome of this overall level of consumption. When I eat a 4th waffle, so you see that my consumption of waffle increases by 1 unit, my TU rises to 110 utils. Therefore, we will say that the MU of the 4th waffle is equal to 10 utils, which means that eating the 4th waffle has generated an extra utility or extra satisfaction equivalent to 10 utils. You can use this type of table. With one good, it's very easy. So 3 columns, quantity, TU, MU. So you see there on the second column that the total utility, it first increases, but you see that it increases at a slower and slower pace. And then it even eventually decreases. You see that it reaches 108. And then if I keep consuming, it eventually starts to fall from 108 to 102. And then I can compute the MU. So we always start at 1 because it is the satisfaction generated by the last unit. So of course, if you have 0, this is not really relevant. And you see that basically MU is just the change in total utility. So for example, let me just use some arrows to emphasize the idea. If I can do it. So basically here, let's use this one, 85. Let's say use 20, for example. 20 is just the difference between 85 and 65 there, if I can. Okay. So basically we had, when we consumed 2 units, we only had 65. When we consume 3 units, we have 85. So the difference is 20. That's the gain in total utility generated by the consumption of the 3rd unit. So the same thing for -6. When we consumed 5 units, we had a total utility of 108. When we consume 6 units, we have a total utility of 102. So the change in total utility generated by the consumption of the 6th unit is negative. So it's -6 utils. Okay, well, again, usually it's quite straightforward. We'll talk about this particular type of utility function in a minute. And you can represent it graphically. Okay, you see that this is your total utility. So it does increase, but at a decreasing rate. And then if you consume the 6th unit, it would actually start to decrease. In A2, we will not consider this type of utility function. I will explain why later. And I can also graph the marginal utility. So we see that it is decreasing as long as it remains positive. Okay, for 1, 2, 3, 4, 5, the total utility keeps increasing. But as long as the MU becomes negative, the total utility actually starts to fall. Simply put, this is because the MU, the marginal utility, is the slope of the total utility function. So if you have, if MU is positive, it means that TU has a positive slope, so it increases. But if MU is negative, it means that TU has a negative slope, so it decreases. All right, that's it. Just remember that. MU is the derivative of TU, simply put. Partial derivative because we have several arguments for the TU function. Okay, stop me if you have remarks or questions, of course. Okay, and you see that this is a good way to introduce the law of diminishing marginal utility. Do not confuse that with the law of diminishing returns. Many students make the confusion, so please emphasize that again and again, because we see in this table that MU decreases. So each, careful on how you make your sentence, each additional unit provides an extra satisfaction that becomes smaller and smaller. So the increase in total utility generated by the consumption of each additional unit becomes smaller and smaller. That's what we call the law of diminishing MU, which simply states that as the quantity consumed of the product increases, the marginal utility decreases. And this is something that students understand pretty well. It's rather intuitive. We all experience this law of diminishing MU. You can take any example that you want. The example that I use is that of someone who is lost in the desert and has not been drinking anything for 5 days, so he's almost dead, basically. And this person finally reaches an oasis with plenty of fresh water, drinkable water. And of course, this person is going to drink, so this water is free. There is no price to purchase it. Okay, and the first drink, the first sip, if you want, or the first glass of water has an extremely high marginal utility because it saves your life. You are almost dead. If you drink the first glass of water, your life is saved. So therefore, your total utility has increased by almost an infinite amount. Then the second drink, you are still very, very, very thirsty. So the second drink still provides a very high satisfaction. So your total satisfaction still increases very much as you consume the second drink in the oasis. The third drink you are still thirsty, a bit less than before, but still you are thirsty. So your total utility will increase a lot. But you get the idea. For each additional drink of water that you will have, your total satisfaction will increase by a smaller and smaller amount. And it's actually possible that you reach a point where you are not thirsty anymore. And actually you've really had enough. And if you keep drinking more water, it's going to make you sick. I don't know if you are aware of that, but you can actually die if you drink too much water. I learned about the story of an American lady who was participating in a challenge on the radio, and the challenge was to drink as much water as possible, as fast as possible, and she died. So yeah, be careful with water. Okay, so it's possible that if you go beyond that point, if you drink above the point at which you are full, you can't have anything else, the point at which your marginal utility would be zero, then your total satisfaction might actually decrease. You would have a negative marginal utility. Okay, so yeah, this law is quite simple to understand. Let's have a look between the relationship between mu and tu. So this slide is one step further, I think. Yeah, okay, that's not so important. If you only have one good, yeah, just remember that mu is just the derivative or the gradient, if you want, the gradient of tu, okay? Not so complicated. And in that case, under the law of diminishing mu is going to decrease, which means the slope is going to decrease. So therefore, if your total utility function has a decreasing slope, then it is concave, okay? Increasing at a decreasing rate. There are two types of possible utility functions. And in A2, we will only study one. You can have preferences that are said to be monotonic, which means that mu is always positive. You will never reach a point, it doesn't matter how much of a good you consume, you will never reach a point where your mu becomes equal to zero or even negative. So it will decrease, become smaller and smaller, closer and closer to zero, but it will never reach zero. Okay, I'll show you that on the diagram. And this is the type of utility functions we will be working on, and I will explain why later. So in this case, if you can always consume more without ever reaching a point where your mu is zero or could even be negative, we say that your preferences are monotonic. In this case, because mu is always positive, even if it becomes smaller and smaller, it always remains positive. It means that the slope of tu is always positive. So your total utility function is always increasing. Okay, so yeah, it will become flatter and flatter as mu decreases, but it will always remain increasing. Just like a square root function, just like a logarithm function, it increases at a decreasing rate, but it's always increasing. So that's, okay, let's start with this one. Monotonic preferences, you would have something like that. So you see as the quantity increases, mu decreases, but it always remains positive, just like the function 1 over x, if you want, something like that. Always positive. So the slope is of tu is always positive, but it becomes smaller and smaller. So the slope is always positive, but your function tu will become flatter and flatter. The other type of preferences would be non-monotonic preferences. So non-monotonic preferences, this is the example of the guy in the desert. There is a point where this guy is not thirsty anymore. And if he keeps drinking, it's actually going to decrease his overall satisfaction. MU would become negative. So what happens in this case is that MU decreases, just like in the case of monotonic preferences. But the difference here is that you reach a point that we call economic satiation, where your MU is equal to 0. And if you kept consuming above this point, then MU would actually become negative and your total utility would start to decrease. Remember that MU is the slope of TU. So if the slope becomes negative, it means that your function starts to decrease, okay? But again, we will never work with this type of utility functions in A2, simply because if we have a situation like that where it is possible that if we consume more, our utility will decrease, we don't know if the consumer is going to spend all its income, okay? Let's say that I have $1,000 and I can only buy Coca-Cola, and today I have to spend $1,000 on Coca-Cola today. I'm not going to spend all my income, right? I'm going to buy, let's say, the 2 or 3 bottles at most, and then I will just stop, simply because if I spend more money on Coca-Cola, if I drink more Coca-Cola today, I would become sick. This would decrease my satisfaction. So in this case, if it is possible that we reach a point of economic satiation, we don't know if the consumer is going to spend all of its income. So we don't know if the equilibrium point is going to be on the budget line or below the budget line. And in this case, we are in trouble. So that's why we will always assume that preferences are monotonic. So MU is always positive. We can always increase our satisfaction by increasing our consumption. So in this case, the main advantage is that we know that the consumer at the equilibrium will always spend all of its income. So that's easier. We know that the equilibrium point will be on the budget line, and that makes our work considerably easier. Okay, in the case of two goods, you don't have to do that. It's a bit more advanced, but you can introduce that. So X and Y, okay. Same thing, I have already defined that. Yeah, so that's the same thing, but now we say that the MU function, so now you have two functions because you have the MU of good X and MU of good Y. So they are the partial derivatives. Perhaps in physics, so for those taking further math, they may have studied partial derivatives. Otherwise, you can really skip that. And this would be the shape of a utility function where you have two good. This red axis would be the quantity of good X. The green axis would be the quantity of good Y. And the blue axis would be the total utility. So you would have this type of surface that would represent the total utility. And you see that what we have there, the dark curve, this is going to be an indifference curve. A set of combination of good X and good Y such that the total utility is exactly the same along it. And actually that's perfect because this is what we will do today. Well, that's how we are going to conclude our webinar today. I am going to introduce indifference curves, and then I think I'll stop here for tonight. So tomorrow or during our next webinar, we'll start again from the MRS, the marginal rate of substitution. Okay, so what is an indifference curve? Easy. It's the set of all the possible combination of two goods such that the individual is indifferent. So being indifferent means that these combinations, they generate the same level of total utility. Okay, so I can have, let's say, if let's take the level of total utility 100 utils, and I can only consume two goods, pizzas and Coca-Cola. I can either achieve this level of total utility, 100 utils, by getting one pizza and 3 bottles of Coca-Cola, or 2 pizzas and 1 bottle of Coca-Cola, okay? If I give the choice between the consumer to get either of these baskets of pizzas and Coca-Cola, let's say for the same price to simplify, and in that case, the consumer will tell me, I don't care, simply because it provides the same level of total utility. That's it. So as you move along an indifference curve, the level of total utility remains exactly the same. So if you are, let's say, on the top left of an indifference curve, you have a lot of good y and a little bit of good x. And if you are on the bottom right of the indifference curve, you have a lot of x and not a lot of y. So what are the properties, the important properties of this indifference curve? They are, okay, first one, indifference curve further from the origin represent higher levels of total utility, simply because the further away you are from the origin, the more of x and y you have. Okay, if you are very close to the origin, a point very close to the origin is associated with a low quantity of x and y. And if you are very far away from the origin, it means that you have a lot of good x and a lot of good y. And since preferences are monotonic, the more you consume, the greater satisfaction you get. The further away you are from the origin, the highest total utility you have. When consumer preferences are monotonic, the indifferent curves are decreasing. Yes, they have to be decreasing simply because if you consume more of one product, okay, let's say that we consume one more unit of x, because preferences are monotonic, I know that this is always going to increase my total utility. So if I want to get back to my initial level of total utility, I have to consume less of y, okay? I get one more unit of x, my total utility increases. If I want to get back to my initial level of total utility, so I am on the same indifference curve, then I have to give up some units of y, okay? So more x, less y. You see that I'm going to have a negative relationship between the change in x and the change in y. So the slope of the indifference curve is negative, decreasing indifferent curves. Under the law of diminishing mu, the indifference curves are convex. I'm not going to say anything for now. I will explain it later when we look at the diagram. But yeah, they are weakly convex. In the case of perfect substitute, we'll see that the indifference curves are a straight line, but this is a very particular case. And because of transitivity, do you know what transitivity is? It's just in mathematics, right? Let me just write it briefly. So in math, transitivity will be something like if, let me write it, if A is greater than B and if B is greater than C, then by transitivity, we can say that A is greater than C. Okay, that's what we call transitivity in mathematics. So with transitivity, it is impossible that two indifference curves will cut or cross-intersect each other. So again, I will explain that with a diagram. So just bear with me for a second and I will illustrate all that. So these indifferent curves that satisfy these properties, we call them well-behaved indifference curves. And we will see that later. Before you move on, what you can do is to ask students if they have ever if this concept of indifference curve make them think of anything else in real life. And for those who know how to read a map, then you can make the analogy with contour lines. When you go hiking, if you look at a map, the altitude is indicated on the map using these contour lines. And you see that if you move along one of these, we also call that iso altitude lines, the level of altitude remains the same. You see, for example, that we have 200 meters, 300 meters, or feet, I don't know, 400 meters, and so on. So you see that thanks to these contour lines, you can have an idea of the altitude of a mountain on a map. A map is flat, so it only has 2 dimensions. A mountain has 3 dimensions. But thanks to these contour lines, we can have an idea of this 3rd dimension altitude. You can also show them this example. So we call that ISOBAR curves. So that's the same idea, but here, if you move along any of these curves, it's not altitude that remains constant, obviously. It's the atmospheric pressure. So here you see that you have different levels of atmospheric pressure. So it's roughly around 1,000. I forgot the unit. It's Pascal something, right? Sorry, it's very, what is HPA, hectopascal, right? Something like that. That's the atmospheric pressure. And as you move along any of this isobar curve, the atmospheric pressure remains exactly the same. Okay, so that's really the same idea as an indifference curve. Well, same logic anyway. So how do well-behaved indifference curves look like? So first, remember, we still have like the horizontal axis is the quantity of x and vertical axis is the quantity of y. As we move further away from the origin, the total utility will increase. Delta TU positive means that the change in total utility is positive, so that's an increase in total utility. And they basically look like that. You can have several, of course, indifferent curves, and actually you have an infinity of indifference curves, one for each possible level of total utility. So we are not going to draw 2,000, 2 billion indifferent curves. We will only draw usually one or two. But of course, you would have many, many, many. So each of them is associated with a given level of total utility. Since the further away we are from the origin, the higher the level of total utility, then we know that TU3 is greater than TU2 and TU2 is greater than TU1. Good. You can, same thing, just like for the budget line, you can use this point and you can ask students about that. You can ask them, for example, what do you think the consumer will prefer, point A or point B? So your students should tell you point A. How about between B and C? Your students should tell you the consumer is going to be indifferent. And how about between C and D? Same thing. Well, your students should tell you the consumer will prefer C. It is on a higher indifferent curves. And between A and D, of course, by transitivity, you could argue that A is going to be strictly preferred by consumers. Let's prove that it's not possible that this happens. So if we had two indifferent curves that, well, intersected, this is what we would have. We see that point, we have two indifferent curves and two different levels of utility, right? Because each indifferent curves shows a different level of utility. So on the one hand, we see that A and B are on the same indifferent curves. So the consumer should be indifferent between A and B, okay? A and C are on the same indifferent curve. So the consumer should be indifferent between A and C. But then by transitivity, we should have a situation where the consumer is indifferent between B and C, which is not the case because they are on indifferent curves. This symbol here means indifferent. So the consumer is indifferent between A and B, same indifferent curves, TU2. The consumer is different between A and C, indifferent between A and C, same indifferent curves, TU1, but the consumer is not indifferent between B and C because they are on indifferent curves. So transitivity is not satisfied here, so it doesn't work. So make sure that when your students draw multiple indifferent curves, make sure that they do not cut each other. That's impossible. Okay, this is the last, yeah, almost done, guys. Okay, I think you can skip this. This is again one step further. This would be a situation, this would be what your indifferent curves would look like if you had non-monotonic preferences. So we would still have the decreasing and convex section. But then if you consume, let's say this is MU, this is the point where you have reached economic satiation, where you have consumed enough of good Y. If you consume above this quantity, if you consume more Y, then MUY is negative. So your utility, your total utility would decrease. So if you want to stay on the same indifferent curves, you have to consume more X, okay? So to stay on the same indifferent curves, you have to consume more Y and more X. And that's why your indifferent curves now has this shape. You see that if I start from this point, if in order to stay on the same indifferent curves, I consume, I'll try to show you, perhaps there. Yeah, I have to consume from C to D more X and more Y, simply to compensate the loss in total utility generated by the fact that I have consumed too much Y that has made me sick. So I need to consume more X to compensate the damage generated by this excessive consumption of Y. And this is the same thing there. For example, if I start from this point, so at that point, I have consumed enough of X. So if I consume more X, if I move even further to the right from here, MUX would become negative. So my total utility would actually decrease because I have consumed too much X. And in order to compensate that damage, I should consume more Y. So same thing, I should consume more X and more Y to remain on the same level of total utility, right? Your students really don't know to know that. It's just for your personal interest if you want to think of what would be the shape of an indifference curve when preferences are non-monotonic. But this is far beyond the scope of the syllabus. How about something that is interesting and that your students might want to know, even though it's not going to be tested, okay? That's why you have the one step further start. What in the case of perfect complements? So if, for example, if I only drink my coffee with 2 sugars, then in this case, you could represent different curves and they would look like that. Let's take point D, for example, to understand. If we start from point D, I have 2 coffees and 4 sugars. Okay, that's good. So I can drink 2 coffee. If I take, if I buy more sugar, let's say, okay, so I start from point D and I'm going to buy more sugar, let's say 2 more sugars. Okay, so I move from D to this orange cross there. So I have 2 coffees and 6 sugar, but because I always drink my coffee with 2 sugar, I'm not going to use these 2 additional sugars. So they will be useless, and that's why they will not contribute to increase my total utility. So I will be on the same indifference curve as before. If I now start from, again, this orange cross again, and I buy 1 additional coffee, so I move from this point to point A, then in that case, my total utility will increase because I now have 3 coffees and 6 sugars, which I can combine in optimal proportions, and I will be able to enjoy 3 coffees with 6 sugars. I will use everything that I have purchased, okay? So think about it, look at this diagram. Not quite complicated. Again, I don't want to spend too much time on that simply because it's not going to be tested. But for you, again, for your personal interest, feel free to have a look at that and to think it through. And finally, and I think that this is the last thing, let me just check. I thought I had perfect substitutes. Perhaps there. Is it later? Oh no, okay. Okay, then what I'm going to do, it's probably on another PPT because I really thought that I had the case of perfect substitutes because this is something, there are some MCQs about that. Okay, I know I did it. I don't know where it is. I will find it, don't worry about that. So okay, let's stop here for tonight. I want to find this diagram on perfect substitutes. This one is interesting. And next webinar, we will start from this perfect substitute case to see the shape of indifferent curves in the case of perfect substitutes. And we will introduce a very important concept that is the marginal rate of substitution. And once we are done with that, we will be ready to bring things together, budget line indifferent curves, and to find the equilibrium of the consumer, to explain how this works. To talk about the equimarginal principle and to use diagrams to represent the consumer equilibrium. All right, do you have any questions before we wrap this up? Any questions? Let me know if you do. Is this okay so far? Is this clear for everyone? Okay. No questions? All right, thank you very much for joining tonight. I will let you know when I organize the next webinar, but it's likely to be tomorrow, okay? Yeah, so we can continue tomorrow studying consumer equilibrium. In the meantime, have a nice evening and enjoy the beginning of your weekend. Bye-bye.